Okie dokie. Here we have a skydiver jumps out of an airplane and falls until they achieve their terminal velocity. A. What is the relationship between the force of gravity acting on the skydiver and the drag force acting on the skydiver when they are traveling at terminal velocity? State the relationship here and explain briefly in your written work. Okay, so if you've got your skydiver and they're accelerating and they're accelerating and they're accelerating under the force of gravity, that means that the force due to drag is going to be getting bigger and bigger and bigger, and eventually it will be equal in magnitude but opposite in direction to the force of gravity. And when this happens, well, the net force is 0. So that implies that the acceleration is 0, and that implies that we have reached terminal velocity. In other words, v is constant unless you change something about the skydiver. Okay? So that's the relationship. Equal in magnitude, opposite in direction as drawn, and that's a little bit of the reasoning behind it. B, skydiver then opens their parachute. A moment after the parachute opens, compare the drag force on the parachute skydiver system to the force of gravity on them. Enter your answer here and then draw a free body diagram of the system in your written work. Okay, so we've got now a skydiver and we've got a parachute. Okay, something like that. Sweet drawing skills that I've got. And, well, I mean, clearly the skydiver was carrying this thing along with him, so the force of gravity isn't going to change on this. It's going to be the same as it is in the diagram I did for part A. But in that moment, after it actually unfurls, well, you've massively increased the cross-sectional area of the object of the skydiver slash parachute system. And so in that moment, right, the force of drag is going to be huge compared to the force of gravity. And that's because you're going to reduce the terminal velocity. And so if you were going 100 meters per second up here, or actually that's unreasonable. What is it? It's more like 75 meters per second or something like that. But in any case, if it was 75 meters per second up here, and now you've reduced it to, 15 meters per second, well, you must have had some acceleration that is in this direction, right, to slow down the velocity that would have been down this way. And so, so going from there to there. And so you must have this unequal set of forces for at least a little while, so that you get this effect. So you reduce your terminal velocity of just the skydiver to skydiver with parachute deployed. And to get that to happen, net force needs to be up. So the force of drag suddenly gets very large. Eventually, if you play the tape forward, another several seconds, maybe 10 seconds or something like that, well, now, and at that point, the forces have to be in equilibrium again because you're back at terminal velocity, albeit a smaller one. Okay? So that's the idea, okay? And that's all you needed to do.